One of the most important concepts that you will learn in this course is the importance of ionic compounds in water, what we call electrolytes. The electrolytes are compounds that dissociate in water and there are charges in water. We've said that the ionic compounds are very strong. They interact very strongly, that positive and negative charges are very strongly attached to each other. This is why to melt an ionic compound, think of how to melt a rock, you have to increase the temperature to the thousands of degrees. However, there's a specific solvent, a specific compound such as water, who is able to break those ionic compounds and stabilize the different charges alone. And this is what we call the dissociation of ionic compounds in water. In this case, when you throw some table salt in water, what happens is the oxygens of water will surround the cations and the hydrogens in water will surround the anions. Remember that water has an electron dipole, so it makes sense that the negative part of water is attached to the cation of the salt. So this means that what used to be an anion and a cation altogether, now in solution what you will have is a cation and an ion separate from each other. And we will talk about this situation using the symbolic notation AQ from aqueous. So it's very important to practice, and so we will practice a lot throughout this course. But let's start, see what kind of species we actually have in solution, because sometimes in our body, in medicine, in so many other instances, maybe only one cation is important or one anion is important. So it's very important to realize what do we have in solution. So when we throw these solids in water, what are the ions that we obtain? So we have to balance the reaction. So notice we have 3 chlorines, and chlorine is, each of the chloride is negative. So that means that aluminum has to be positive, 3 positive, so that it's neutral, right? 3 negative from the chlorides, 3 positive from aluminum. In here you'll have, notice that the metal will always be positive and the non-metal will always be negative, because non-metals are more electronegative, therefore they keep the charges. How to figure out the charges here? Notice that this 2 can be just moved from here to here, right? So the 2, I wrote selenium, it's actually sulfur, 2 negative and positive, and do not forget to write the coefficients. So how many irons do I have? I have 2 irons and I have 3 sulfites. Okay, the same for magnesium chloride. You will have magnesium and 2 chlorides. That means this will be a 2 plus. Okay, we will practice way more, but at least this is the beginning.